So some of you guys might, like some of your parents might say sometimes that you're not being logical or something like that. And a lot of this is just kind of like, what comes next based off of what we already know. So, and there are rules that go with that. It's not just like because I think it should come next. So, looking at the pattern, questions are really big ones for the test that you'll take as a junior called the ACT. We review those from time to time throughout like your high school career because the ACT is such a big, important test that you guys end up taking as juniors. Now, as freshmen or sophomores, or even like when we have 8th graders in here, it might seem a little silly that we're talking about it already, but it's not just content you've learned in your like sophomore year. It's stuff you learned all the way back in middle school and maybe even elementary school. So just kind of reviewing some of that and just helping you guys to get better at the test so you really can do your best to show what you know. And even if you're thinking at this point, I don't know what I'm going to do in my future, you don't want to set up walls for yourself. You want to make sure you're doing the best you can to kind of get yourself ready to go wherever you're going to go next from here. One of the things that we do on those Wednesdays that you guys have AR is during AR, we'll practice for the ACT. And again, that might seem kind of silly at this point in your life, but it's going to be useful, I promise. I wish I got into the school I wanted to get into, but it probably wouldn't have hurt for me to prepare more for the ACT than I did. So, so in our patterns here, so the first one is kind of talking about what we're talking about today. And then the second one kind of reviews what we talked about last class, or last chapter. So looking at the pattern, does anyone figure out what shape can come next after this? So maybe we'll do some votes here. Who thinks it should be letter A? Vote with your hand. Any letter A's out there? All right, how about letter B, which is down below? Letter B. Some B's. How about C? Got some C's. How about D? D. All right, so it's asking for what the next pattern is. So it's starting here. So we start with like a stop sign. And then what happens in the next one? How would you guys explain that to someone who can't see the pattern? How would you explain it to someone? What's happening? What happened from here to here? See, how would you explain it? So I would explain it as the fact that this was a corner before and now it's gone, right? So that corner is now kind of like popped out on your stop sign. So that corner popped out. The next one, what happened? The next one kind of came out, right? So now this one is going. So that would make you think what's going to happen next, which is going to be the next corner. Do you think it's going around this way? I guess that's what I would think, that now the next corner would be this one down here, so that would take us to B. Maybe some of you guys might argue that C makes sense, like maybe the way we read, that it goes here, here, and then here and here. So I don't know if I consider this to be a great question because of that like maybe there's a different pattern. But typically, things in terms of patterns go like in a cyclical manner, so that they keep going around this way, not the way we would read, so keep going around this way. So I would agree that it should be B. Right, this way. Making marks on that word for me. Okay, the next question is a tricky one because it has really smart wrong answers. So when the ACT writes their questions, they don't just write out random other answers that could be choices. They figure out what common mistakes would happen. And I mean, people who write good tests try to do that. So when I when I give multiple choice questions on our test, I don't just pick random letters to be the angles. I try to see what would you maybe think would make sense, and it's actually wrong. So in this problem, there's a really great wrong answer in this problem. And the reason for that is they want you to read the question. So it says, which of the following is equal to 2x? Nowhere in this problem do they discuss a 2x. They discuss x, but 2x is kind of like, why would you want to know that? But they ask questions like this all the time in the ACT, making sure you're actually reading the question. So what did you guys do to find like the solution for this? So kind of take me baby steps through this. What was your first step? This was like just from our last test. So this would have been a question I could have put on our last test. What did you guys do first? You guys, what equations did you set up? What do you think? Anyone write anything down? Too many equations here. Good guessers. Right. No. Right, someone tell me you did, Michael.
X plus 25 equals 180.
Okay, yep, so maybe you just did that in your head and you didn't write it down, that's okay. So Michael said x plus 25 should equal 180. They're a linear pair, so they make a straight line together. So I saw a lot of you guys figure out the answer should be 155 because you subtracted 25. And like I said, maybe you did that in your head. So maybe you didn't write this out. And on a test like the ACT, those of you guys who don't like showing your work, it's perfect for you because you don't have to show any work. The ACT does not take off points if you don't show your work, your answer is correct. I would like you guys to show your work just so that if you do make a mistake, I can figure out what you were up to so I can give you some partial credit. You'll hardly ever see me give you like no points on a problem if you gave me some work. Now, this is where you could go wrong. You're trying to whip through a test, a time test, the ACT is a time test, and you might see 155, there it is, bam, I have my answer. And so you stop, you just answer it as 155, you're excited you see that answer. Again, the ACT is trying to kind of slip up, like get you caught into a mistake. And I try not to do this on my tests, but it's probably something I probably should do just because a big test does that to you guys. It's asking for what is 2x. So once I find x, I still have to figure out what double that x is. So I still have to put that 155 back in to then figure out what 2x is. And that's how we get 310. So it's kind of sneaky, and think about it, if you have 60 questions like this, and you're like, I see my answer, I'm gonna move on, it's really easy to just be happy that you see the right answer, and it's really not. It's just a kind of a little bit of a myth there for you. So be careful on tests, like multiple choice tests, especially that way. I try not to kind of catch you in a mistake, so that's why I have all the different lines that ask you different questions. But this is, some tests are set up that way. All right, so we're gonna talk about something called conjectures today, and it might be something you've never even heard of. We're also gonna talk about something called counterexamples, which might be something you can kind of figure out maybe what that means. But a conjecture just sounds like a really sounds like you're trying to use a really fancy word to sound smart. Like my conjecture is, I mean, you probably wouldn't use that in your everyday language. But inductive reasoning is something we use all the time. We just don't call it inductive reasoning. It's using patterns that we observe to make a conclusion. Use patterns you observe to make a conclusion. And that conclusion has a fancy name in geometry called a conjecture. So a conjecture is just the conclusion we came up with based off that pattern. problem 1, we made a conjecture based off the pattern we were observing. And like I said, we do this all the time. I mean, probably, I think that we in life probably let ourselves down a lot because we do this so much. So you kind of expect something, like if you, every, time you won a baseball game, your mom takes you for ice cream afterwards. I mean, you expect that the next time. Same idea like today, it's a nice day outside, so I think you're maybe gonna think that maybe we'll go outside. You're not gonna make a conclusion like, if it's nice outside, maybe she's gonna take us to Six Flags today. Like that's kind of a weird conclusion. Like that wouldn't be a great conclusion based off the pattern. I've never taken you to Six Flags. You probably know that that's probably unlikely that I would be able just to take us all there. But going outside, that seems reasonable. That's a pattern. I've seen that happen. So like we do this all the time in our life. And like I said, I have a hard time with probably doing this and making that conclusion a lot and then kind of letting myself down where I expect something because we've done that same thing over and over again. If that happens, we get to do this. And so I'm excited for something and then it doesn't work out. So we use inductive reasoning all the time in our life. Okay, well, what do you have out? What do you have? You don't need your calculator right now. Okay, we will in a second, but I thought it was your phone, so I apologize. But, okay. So using that conclusion to make our pattern. Okay, so now, yes, you do need, sorry, I thought initially you had a cell phone out, but so you might see there's an example going on here where it says 2, 4, 12, 48, 240. We can make a conclusion based off of what we see. Now you might, like something crazy might happen. Like if this was a real life situation and maybe these are like COVID like numbers, like the pattern might not hold true. Like the pattern might not actually be a thing and it just happened to work out that way. It might be a coincidence. But if we're asking to make a conclusion based off of inductive reasoning, it's okay to assume the pattern exists, okay? So you can say, well, maybe something weird will happen, or we'll figure out here's where the vaccine comes in, and then we're all good. Like that's not, we're assuming that it continues on. So yes, sorry, Will, you can grab your calculator if you haven't already. See if you guys can figure out the next number in the pattern, and we'll talk about what's gonna happen next. And you probably want a calculator unless you're really good at multiplying big numbers in your head or on paper. What do you guys think you have here? What do you guys think is the next line going to be? What do you get, Luke? 1,000. You guys agree with him? All right, how did he get that? Because if we all got that same number, that's pretty crazy. We're all like some sort of magicians that we can figure out the next number is going to be. How did he come up with that? Well, what were you doing on your calculator to get to that? What was happening down here?
It was, well, first of all, it was going by twos and then it multiplied, 4 multiplied, no. Yeah, 12, then
What?
it's timesing itself by 2, and then it's doing it by 3, then 4.
There you go. There you got it. I know sometimes it's hard to say it in words, like what's really happening. And so what we'll notice was it started by multiplying by 2. So then it kind of made you wonder, oh, are you multiplying by the last number? Well, no, because then you try that, and 4 times 4 would be 16. But 4 times 3 gives us 12. And then you maybe say, well, maybe there's a pattern there, and try that. So sometimes it's a little bit of trial and error, and some of you guys are gonna be better at it than others. Some people just don't see patterns as clearly, and I just suggest you try different things. Try adding, try multiplying something by itself, bless you. Try multiplying by another number in the line. Because you might start by saying, well, maybe you're just adding 2. Then I'm adding 8. Whoa, then I'm adding, is that 36? Like that doesn't seem to make sense, but adding. So sometimes you have to try different things and see if you guys can figure out what the pattern is and kind of test it with the next number. I will try to give you guys patterns that don't have multiple outcomes. But like I said, we're using that inductive reasoning. So it's a pattern based off our observations. Now, again, this doesn't always happen in real life. So, like kind of the idea of luck or just real life happening. Like I said, if these were like numbers of infection rate and there was this great pattern, there's nowhere in the world that says that pattern has to continue for COVID numbers or for whatever else it happens to be. So this is just, it happens to keep going. It seems to make sense. We multiply by 6 then, and that's how we get 1,140. So sometimes just trying things, and some, like I said, some of you guys will see it more quickly than others. All right, let's look at our next one here. So we have this triangle thing drawn, and it says make a conjecture about the pattern. Find the next item in the sequence. And what I want you guys to do, and also I want you guys to look at the number of segments. So if you think about these as toothpicks. So in this first one, there'd be 1, 2, 3 toothpicks. And then in the next one, how many toothpicks would there be? So you're trying to find the next, what's the next drawing gonna look like? How many like toothpicks would be in that drawing? And we're gonna try and make a conjecture, like make a conclusion and kind of see a pattern there. So you guys can draw the next item in the sequence, see if you guys can see a pattern there in terms of what's gonna happen, what would happen in the one after that, what would happen in the one after that. You don't have to draw them all, but see if you guys can find different ways to describe it. I'm just writing the number of toothpicks up here. And if your drawing is not good, don't like stress about that. Don't think I'm gonna judge you on your drawing skills. But we want to talk about what the shape is going to look like, and then also how many segments are going to be in that. How many little toothpicks would be in our drawing or in our figure if we were actually putting this out on our like desk or something. It seems like it'd be helpful to actually have toothpicks, but I have to buy like the special flat ones because otherwise they like roll away on your desk, and that could be more frustrating than just about anything here. So, all right, what do you guys think? What is the drawing going to look like? How would you explain what you need to do to it? What's happening each time? Go from 1 to 2 to 3. What's happening each time? Or does someone want to talk about the number of toothpicks? Tell me something you guys observe. Yeah, Hayden. It's doubling.
Yeah, times 2 over 20.
So times 2, so what part's times 2? So like, what's the,
3 for 2 things.
yeah, for toothpicks, so what's the next one gonna have? How many toothpicks will it have? Did you figure that one out? You think 36? Do you guys agree with it? And so, okay, so that is Peyton's conjecture based off the pattern he sees. It may have some like flaws in it, and so sometimes we have to check it more than one way. Because he kind of sees this pattern with the numbers. There's 3, 9, 18. To him, the next one that makes sense is 36. Because he's thinking of it as doubling. Except if you double 3, it's actually 6. So there's a little hole in your like reasoning there, and that's okay. We're trying to like show that you might think of something and then say, well, let me try and draw it and make sure it works or it doesn't work. So let's talk a little bit more about it. What do you think, Luke? You got 30. 30. Where'd you get 30 from? Did you just draw it?
I just drew the more triangle thing.
Okay. So he said he drew the more triangle thing. So what that means, let me move this whole thing. So I'm going to clone this because I'm going to cheat because I have technology. What gets added onto that thing? Another row, right? So like a whole other row. Like I said, I have technology, so I apologize. And even mine doesn't look that good. So it's a whole nother row. Do you guys agree that's what it should look like? So another row got added on. And so maybe it's worth counting the toothpicks or the shapes. Otherwise, you might see a pattern here. So we talked about doubling times 2. That doesn't quite work because 3 times 2 would be 6. But 3 times 3 is 9. But then 9 times 9 is an 18. So my pattern there that I'm seeing isn't quite making sense. So what's happening with the numbers down here? Anyone see a pattern here? What do you think, Will?
It's getting smaller.
Oh, like the number you're adding or multiplying by? Oh, so you're saying times 3 times 2, but then wouldn't this one be times 1?
Yeah.
And then it would stay the same size. No, I like your ideas. Like I like that you guys are willing to try things because I do this in my head all the time. Like I'm like, it just some of you guys see it so clearly, and then others of us like have to try different things, and that's okay. So that doesn't work. So if multiplying's not working, what else should we try? They're going up, so maybe try adding. How much different are these two? 6. They go by 6. How much do we go up here? 9. What do you think we might go up by now? 12. So that's how we get our 30. So I think 30 is that, because each time we're adding another row, and another row is really just adding an extra triangle onto what we've already had, right? Like, because we had, oh no, it's like you have 5 triangles on the bottom here. So there's 1 triangle on the bottom, there's 3 here, there's 5 here, there's 7 triangles on the bottom there. So there's kind of a lot like of different patterns you might have seen in this drawing, and it's kind of just trying to find different ways to come up with how many segments are in there, what would happen next. So what do you think the next one in the pattern would be? So if I didn't want to draw that out because it's going to start getting really wonky, the next one going to be? So we got 6, 9, 12. Yeah, what do you think?
45.
45? Because this time we'd be adding 15, because each time we're adding 3 more than we had added previously. I think so, and you could try it. And it kind of makes sense that we'd be adding 9 more triangles on this time, right? 1, 3, 5, 7, 9. So there's a lot of different patterns showing up there. All right, so why don't we take a notes break, video break. Go outside, walk around. All right.